Alrighty, let's see what we got here. XOR after range multiplication queries part 1, medium. You're given an integer array nums of length n and a 2D integer array queries of size q. The queries has left, right, k, and v. For each query you must have following in order. Following operations in order. You must apply the following operations first. Set idx to left, while idx is less than or equal to right, so they're like inclusive indices. Nums at that index is equal to nums at that index times v mod 10 to the 9th plus 7. And then increment the value of the index that you're dealing with by k. Okay, so k is kind of the incrementing value. So k is 1, that needs to go through all the indices from left to right by 1 each time, or consecutively inclusive of left and right. But if k is 2, then we'll be skipping over every other. Return the bitwise OR of all the elements in nums after processing all queries. XOR after range multiplications. Okay. So here, queries goes from index 0 to index 2, incrementing by 1, so every index, and multiplying by 4 each time. So multiplying everything by 4 basically, so 4, 4, 4 is the final array values, and then XOR of 4, 4 XOR 4 XOR 4 is 4. XOR, if you have a value XOR with itself, it's the same thing as basically 0, and 4 XOR 0, or X XOR 0 is going to be X. Alright, two queries. Oh, okay, so there could be multiple queries. Okay. So going from index 1 to index 4, so starting at kind of 3, and then this one's incrementing by 2, so it's the 3 and the 5 multiplied by 3, so it becomes 9 and 15. And then going from 0 to 2, so these values incrementing by 1, so every single one of those values multiplying by 2, so it's like 4, this is 9 times 2 is 18, so 4, 18, 2, 15, 4. 4, 18, 2, 15, 4. Right, yeah, and then XOR those values. Huh. Okay. I wonder if I just need to actually do the operations and everything. There's a shortcut. I'm not seeing it immediately. In terms of processing each query, I think I might need to literally process every value in that range. Huh. Do I? Ooh. Can I come up with a single multiplying factor somehow? K is kind of a big deal. If this was every value within a range, I could probably come up with some multiplier that is kept track of, so that there's a current multiplier for the current index, and then it kind of changes based on whether or not it's adding to another query range or removing from a query range. But this K thing makes it so that the ranges have gaps in them. ranges have gaps in them, which makes it so I might want to just actually do each query range. So the query length is 10 to the third. The range of values in the query is 10 to the third as well. So 10 to the third times 10 to the third is 10 to the 6th. That's 100,000. Okay, I'm going to try just the basic thing, which is to actually compute everything and see if that's too slow. So yeah, so I mean, I'm just trying it out, right? Just actually doing the actual simulation of queries for, let's say, n queries. I think I can do a for each loop for the query loop. So for every L, I'll do left, right, K, and V in queries. And then I'll do for index in range of left to right incremented by K. I think it'll be left to right plus 1, since it's inclusive. Nums at index times is equal to nums at index times V, and then this is modulo the value 10 to the 9 plus 7. And then I'm just going to do the answer is 0 for every value in my nums array, answer bitwise or with the value. Okay, so this is hopefully correct. I assume this is going to be too slow, but okay. So it's too slow by half, which is an unusual runtime. Alright, so this suggests, I'm actually not sure why this is anything different than in the middle of the curve of runtime distributions. Because I think this is pretty straightforward in terms of how do you try to tackle this. I mean, I can't really see any other obvious implementation of just doing these queries. I can't see why this would be faster or slower than those implementations. But regardless, I think there is something I can do to optimize this. Huh. There is something I can do to optimize this, maybe. I mean, if it's 0, then it's 0, right? If it's 0, then you can skip it. So maybe I can do if the nums at this index equals 0, then just skip. I'm not sure if adding a conditional check to avoid a single multiplier. Is all that great? Maybe adding that check to everything. Like, Is there any clues here? Like bitwise OR, if you had elements that are the same, two elements that are the same cancel in the bitwise OR of values, so like 4 and 4. 4 bitwise 4 with 4 is just going to give you something that you can ignore those. But the issue, I think, is that I'm not sure how you'd maybe predetermine that there's going to be certain values in the nums array that ends up in the same n value without actually performing all the queries on those values. I guess the only thing is like zeros just never going to change. So like, can you avoid zero somehow? Like you can't delete zeros from the nums array because the indices would change. 0, 2. I guess if a query has a k value of 1, then I can skip it. Or if not k value 1, it has a v value of 1, I can skip it. Because the v value is 0, then it changes all those things. The v value of 0, okay, the v value can't be 0, v value can be 1. So I mean I could do something like this. If v equals 1, then continue. I guess that's the one trivial case. Alright, let's see if this speeds up anything. Okay, so what was it before? So shaved off like 40 milliseconds out of 1400 and somehow, or 1500, and somehow that improved its percentage. Okay. That's still not really that much of where I want to be. I think I really want to be over here. If I can somehow figure it out. It's not multiplying by 0. Is there a linear approach to this? So, or like so this right now is kind of n squared, O of n squared time complexity, because there's an outer loop and an inner loop. The inner loop is kind of O of n, the outer loop is O of n, so it's O of n times O of n. So what would it be to make this linear? Although to be fair, this is not this this distribution in terms of how much of a speed up it is going from 1500 to 750. That doesn't seem like it'd be a linear. That doesn't seem like it'd be a change in order, the growth order of time complexity from O of n squared to O of n. That seems more like just a optimization thing. If it was a difference between O of n and O of n squared, then I'd really expect the constraints of this thing to be larger so that it would make O of n squared to be kind of incorrect or timing out if I try to submit it. And only O of n squared, only O of n answers is actually going to be within time for a larger constraint. So I really think it might be such an optimization of this O of n squared. In theory, it could be O of n log n. to do? How would sorting it somehow help? If I sorted the queries, if it wasn't for the gaps, I think it might be. If it wasn't for the gaps, the k gaps in the query range. Oh, could I somehow? Could I somehow modify the nums array? So I would need to sort the queries so that I'm dealing with the lowest left bound query. And then I do what exactly? So the fact that it does this XOR thing, or the fact that it does the XOR, but also before that does the multiplication with modulo. I think I really do need the result. Like I can't do something where, for instance, I XOR all the values in the original nums and then try to find some extra factor that is applied to that original XOR of all values to get the final result. Yeah, like I don't think I can do something where XOR like 2, 3, 1, 5, 4, and then do some more XORs, somehow get 31. I don't think so anyways. Because this 18 could be something that loops around from the modulo. I mean, I could be wrong about that. Could be wrong about that. Huh. Are there any 0 values in this nums array? So everything's non-zero. Everything's non-zero and it's prime. Okay, so I don't have to worry about zeros. Actually, now that I think about it, okay, maybe that last statement was wrong. Maybe I can XOR all the nums values and then. Okay, I think I got it. It's the fact that if I multiply, it's the fact that if I multiply the values by v in the query, so multiplying 3, it keeps that 3 buried within the multiplication. I think that means that I can keep it as a 9 maybe. Let me double check. So if my nums were something like 1, 2, 3, or let's say 2, 3, 4, and I have a query that is, let's say 2, 3, 4, 5, and I have a query that is from 0 to 2 going up by 1, multiplying everything by 3. So originally this is 2 XOR 3 XOR 4 XOR 5, and now this is 2 times 2 XOR with 3 times 2. No, sorry, multiplier is 3. XOR with 4 times 4 times 3. Oops. XOR with 5. So I'm trying to see if there's a simplification here, like can I factor out or somehow pull out the 3? The 3's cancel. So this ends up being 6 XOR 9 XOR 12 XOR 5. XOR calculator, please. Actually, I'll just use Desmos. I think I can use Desmos here. Can I use Desmos? 6 XOR 9. Is XOR, is that something? Alright, fine. XOR calculator. Six XOR, I don't know why they have this base 16, that's stupid. Oh my god. Default should be decimal. 6 XOR 9 is 15. 6 XOR 9 is 15. 2 times 3 is 5. Or no, 2 times 3 is 6. What am I thinking? So this becomes 15 XOR 12 XOR 5. So 15 XOR 12 is 3. Interesting. 3 XOR 5. I should probably be better at this. 6. So this ended up all being 3, huh? 3 XOR 5. 2 XOR 3. Let me go ahead and just do XOR rules, properties. So there's a transitive or associative property, A XOR B XOR C is, you can do whichever order of XOR. A XOR B is B XOR A, that's fine. There's no kind of multiplication property within it, looks like. Based on these properties that are listed here. 2 times 3, 3 times 3, 4 times 3. 6, 9, 12, 5. Do I have to literally look at the binary here? Fudge. Okay. So binary 2 is 1, 0. So I'll do maybe 3 digits here. 3 bits. 3 is 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. So if we multiply it by 3, it becomes 6, right? So 6 is going to be 1, 1. Okay, I think I need 4 bits here. So 6 is going to be 0, 1, 0, not 0, 1, 1, 0. So 4 plus 2. 9 is going to be 1, 0, 0, 1. 12 is going to be 8 plus 4. And 5 is going to be 0, 1, 0, 1. Alright, so actually, what is 2 XOR 3? XOR 4, XOR 5. Let's try to calculate this out. 2 XOR 3 is going to be, so XOR has to be one or the other, but not both. So 0, 0, 1, XOR with 1, 0, 0, XOR with 1, 0, 1. And that should be 1, 0, 1. XOR with 1, 0, 1. So that becomes 0. So 2 XOR 3, XOR 4, XOR 5 should give me 0. Give me 5. Right. So this thing ended up being 6, huh? 3 XOR 5. So let's do this here. This is going to be 1, 1, 1, 1. So it's 15. And then 0, 0, 1, 1. XOR with 0, 1, 0, 1. And then 0, 1, 1, 0. Okay. 3 XOR 5. Is there any pattern there? When I multiply it by 3, is there any pattern between before and after multiplication by 3? I guess probably not. Six times 9 times 12. 6 times 9 becomes 15. 2 times 3 is 6. 2 times 3 is 6. Alright, let me do 2 times 3. 2 times 3 times 2 XOR 3 times XOR 4 XOR 5. If I insert a multiplier by, I don't think there's anything. Is there any simplification here? Like some number times k, XOR some other number times k. XOR properties. XOR products. XOR properties on products. Like A XOR. Yeah, this is kind of cool. This XOR swap algorithm. Well, XOR is a bitwise modulo, bitwise addition modulo 2 when working with polynomials or products. XOR function says addition operator allowing for as an addition operator. What is this? Can I read this? I don't know if I can read this. The 5 properties of exclusive of the XOR operation in GF of 2 to the n field makes this operation a very interesting component for use in a block cipher, closure, association, blah 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 blah. I learned what GF of 2 to the n is, but I cannot understand the meaning of these properties. Consider God. Is it? Alright, I think I want to do one test case here. Like this. Alright, I want to do 2 XOR, 8 XOR, let's say this was K's, or the multiplier is 4 instead of 3. So 8, 12, 16, 5. 8, 12, 16, 5. So 8 and 12 is 4. 4 and 16 is 20. 20 and 5 is 17. Yeah, that's not really not really anything. Okay. Oh my gosh. Multiplies the element indices 0, 1, 2 by 2. Yeah. I'm not smart enough for this. It's not obvious enough for my little brain. Okay, anyways. Summary. Unfortunately, could not find more efficient kind of optimizations over the over the most kind of straightforward implementation of the queries being performed on the nums array. So simply iterate over the queries, and for each query iterate over the relevant indices and perform their operation, the queries operation on those indices. Afterwards, calculate the final XOR, the final answer XOR of all values in the nums array. One minor, but I guess it'd be non-insignificant. Insignificant. I think that's how you spell it. Optimization is to skip queries where the multiplier value, which is v, equals 1, since there is no change to the values for that query. Alright, time complexity is O of n squared. Since we're performing an outer loop over the n queries, the queries n goes up to 10 to the third, and each query is can take n operations to iterate over the indices in its range. Right, the left and right indices are 10 to the third as well. Okay, space complexity is O of 1, since no extra space is needed.